Hello everyone, in this video we will be understanding how to interface an ESP01 module with the 4x4 matrix keypad. I will be using a PCF8574 breakout board to combine the 8 pins of the 4x4 matrix keypad and interface it with the ESP01. We will be also extending our previous implementation where we understood how to interface an ESP01 along with the 16x2 character LCD using an I2C bus. We will be essentially setting up our ESP01 along with the PCF8574 breakout board to which the 4x4 matrix keyboard will be connected, and that will again be daisy changed with the I2C bus, that is the I2C backpack of the 16x2 character LCD. With that, there is a lot more to understand in this video. Let's get started.
So before we begin the real circuit, I'd just like to mention that this is the continuation of my previous video where I explained how to connect an ESP01 using an I2C bus with the LCD. And in that, one thing I specifically forgot was making the CHPD, this particular pin, to be high for a normal operation. So yes, do make a note of it. And we'll move further with the pinout diagram of the PCF8574 breakout module. In this, I've specifically added the number pad because it only has the 7 outputs and that have to be mapped to the IO pins side of the breakout board of the I2C bus controller, and the beneath one is actually the flip view of it. So one pin that you can see right here is actually the interrupt pin, which we are not making use of it. Sometimes this might not work as expected, so try to flip up the pins and do it with a hit and trial method. Let's move on to the net circuit, how it looks. Here we have the extended of the previous tutorial. That is, in between the LCD and the ESP01 module, I have added another PCF8574T IC breakout board, and the remaining one has gone in continuation to this. So you might want to pause the video and understand all by yourself. One more thing I wanted to mention is that you can connect two I2C bus controllers one after the other. This is called daisy chaining without affecting the functionality of the actual setup, and you just have to set the analog pins to different addresses. And now we can understand that GPIO 0 is now connected to SDA as usual, and GPIO 2 being connected to the SCL of this particular breakout board. I have, however, not involved the keypad in this particular demonstration because it only refers to the previous way that we have linked this keypad with the PCF breakout board. For the code, I am again back to my GitHub repository named as circuits and code, and since this is the ESP01 related implementation, I'll hop over to the ESP01 folder. In this, the one that I'm looking for is ESP01 I2C keypad LCD. Now in here, I have added the required libraries, the liquid crystal I2C being from the previous session. However, you can download it if you're starting afresh. And this one, Keypad i2c, this you have to install for implementing the I2C keypad. Keypad library is essentially coming from the Arduino specific one. I've just added it here for your reference so that we don't run into the version issues. Let's be back and go into the main sketch of it. At first, you will see I have added specific comments on the connections and whatever essentials you have to be prepared with. We'll hop over to line number 33 to 36 where I have included specific header files for this implementation. Again, a lot of comments. In line number 46 and 47, these are basically the previous code lines, and you can just copy those. The ones which I have added to this particular code is what you can view. So line number 49 and 50, basically the rows and columns of our number keypad. So I have a 4x4 keypad here in this implementation. That's why I've made rows and columns to 4. Then we have created the keys array. It's a double dimensional array 4x4, which totally looks like my keypad. So 1, 2, 3 and A. That's how my keypad is. You'll shortly going to see in the implementation and the working video. In line number 58 to 59, Now, when you talk of the hexa keys variable described in line number 52 versus the row pins line in line number 58 and the column pins in line number 59, you might have to change them a bit based on how your 4x4 keypad is internally wired. So mine was working in this way that the row pins were called as 4, 5, 6, 7. Sometimes they are called P1, P2, P3, and column pins are called C1, C2, C3. So they are numbered right from 0 for the columns up till 3 and from 4 to 7 for the rows. Now next I have added line number 62 for the breakout board specific address, that is 0x20. This is because I have added the address of this PCF pin, basically the PCF8574 breakout board, as 0x20. I have configured it using the analog shifters and the jumpers available on that particular board. Coming to the next, I have set the buzzer time. Basically, whenever we get an input, we beep for 100 milliseconds, and whenever there is an action, there is a distinguished type of beep that is executing for 300 milliseconds. Then we have line number 73. We have all the usual stuff for the LCD setup, which runs on 0x27 address in an I2c chain. When we talk of, it's basically all the I2c buses should have different address. So that's why my keyboard specific PCF8574 has an address of 0x20 that you can see right here, and the one beneath it, that is for the LCD, it has 0x27. There is a method that I've created for beep. Then we'll hop over to the setup method. We have initialized the wire begin from 0 to 2 because we want to initialize the SDA to be starting from pin 0 and SCL to start from GPIO 2 of the ESP01. Basic initialization items for the LCD to get started, and the custom keypad that we have created to also get started, LCD backlight, and some basic housekeeping stuff, following which we have the loop method. So here I'm just infinitely waiting for a key to get pressed and storing its value in the custom key. Now if there is a key pressed, the LCD cursor will set itself to 0. It will give a beep. Now this is an input beep which will ring for just 100 milliseconds, and it would say the LCD would print key pressed, and it would set its cursor to 1,1. Basically it's a 1602 LCD, so we only have two columns, 0 and 1, two rows, I'm very sorry. And then we have LCD print custom key, whatever the key user pressed, that will be there. With a delay of 3 seconds, this message will stay, and again the action beep will ring, and then the LCD will clear itself and again will ask you to press a key. So that's pretty much it about the code. It's highly driven by the library that we use, and just make sure that you have the right ones installed that I have supplied with this code. Now let's see everything working in action. Press the key as the LCD says, and we pressed 5, and so gets reflected over the LCD, and then it clears itself. We'll press another key, and so does that, also gets reflected to the LCD. We can keep on pressing the key, and this will work in loop as we have given the code for this one. And this is how, ladies and gentlemen, you connect a 4x4 keypad along with the LCD over the ESP01 using the I2c PCF8574 bus.
Till now we have set up a very basic input, output and a processing device, that is our ESP01, which itself does, despite having limited number of GPIO pins, acts as a microcontroller with its peripherals, where input device is a 4x4 matrix keypad and the output device is being the 16x2 character LCD. All daisy chained along with it using the IO pins of the PCF8574. Sometimes it's the breakout board and sometimes it's the I2c LCD backpack. With that, we'll conclude this video. I will be coming up with more and more videos, this time for the software development and the coding part of it, how we can enhance the functionality of this particular implementation. And until then, this is Abhyuday Shukla signing off. Bye bye.